Now that we understand the equation to waves, we can now try and solve this particular question. So we have been given an equation to a wave, displacement of a particle. So let me first write that down. We have been given that there's an equation y equals 10 pi divided by 4. Okay, and we have to calculate the direction of the propagation of the wave and the speed, frequency, and the wavelength of the wave. Okay, let's do that. The first step is compare this with a standard wave equation. Our standard equation was a sine with t comes omega plus with x comes k. And we have an additional number over here. That's the phase constant, pretty much similar to what we did in simple harmonic motion. Okay, so if you compare this, we immediately understand that the amplitude is 10 meters. We also know now that the angular frequency, which is defined as 2 pi f, is 100. Whatever comes with t is that. So frequency has to be 100 divided by 2 pi. That's 50 divided by pi. That's the frequency, so many hertz. So we have found what the frequency is. Okay, next step is we can use this to figure out what the wavelength is. K is defined as 2 pi divided by lambda, which is given as 20. So lambda is 2 pi divided by 20, which is pi divided by 10 meters. That's the wavelength. And we can also calculate what the speed of the wave is. We can either do v equals f lambda, because we have that now. So f lambda, that turns out to be 5 meters per second. But notice, if we wanted to calculate velocity, we could have done that without calculating this. We could have just done omega divided by k. Omega divided by k, 100 divided by 20. That's also the same thing. We derived that last time. So either ways you do, we have the wave velocity. Okay, now we need to know at what direction the wave is propagating. Well, remember that if omega t and kx have the same direction, the same signs, which is the case over here, the wave must be propagating in the negative x direction. Okay, so from this we understand that the wave propagates in negative x direction. Ta-da! We have answered all our questions. There we have it.